Today we're going to be learning about how to calculate relative frequency. Well, it sounds like a big fancy term. Really, it's just comparing the experimental part of probability to the theoretical part of probability. And again, we know that the theoretical part is what should happen in an experiment, and the experimental part is what does happen in an experiment. So let's perform a probability experiment. You are going to each get 2 dice, and you are going to roll them for a total of 40 times. So if you want to break it up 20 and 20, that's fine. And then you're going to track the sum from each roll. So a reminder is that the sum is what you get if you add the 2 dice up. So when you're looking at the example here, it would be 6 plus 5, so the sum would be 11. And you're going to create a chart that looks like this to track your information. Now you'll notice there's no sum of 1, because if you're rolling 2 die, the minimum sum you can get is 2. You could get a 1 and a 1, which would add up to 2. And the highest number is 12, because the biggest number you could get is 6 on each die, and 6 plus 6 is 12. So I want you to pause the video until you've rolled and recorded a total of 40 times. Again, you can do this 40 times each if you'd like to do your own experiments, or you can combine your efforts and divide it up so you have a total of 40 rolls. Alright, now you have a chart that looks like this, only yours is all filled in with your tally marks, however many times you rolled each number. This chart has a name. It's actually called, a frequency diagram. Spell check there. Now yours is obviously going to look different than this. Hopefully you have something in each and your numbers are different, but just to show you what we're doing with this going forward, I've done a couple of examples here. So the next thing I want you to do is figure out the total number of times you've rolled each. So in my example, I said I rolled a 2 twice over a total of 40 rolls, because that's how many we were asked to do in the experiment. So I represented it as a fraction of 2 over 40. I rolled a 3 5 times. So I represented that as a total of 5 over 40. And then I said I rolled a 4 6 times, so I represented that as a fraction of 6 over 40. Now we know we can also represent these by percents by changing this fraction line into the division operation. So if I wanted to find out what each of these was as a percent, I would simply divide my outcome that I got over my total number of outcomes. So in the first case, it would be 2 divided by 40, 5 divided by 40, and 6 divided by 40. When I do that, I get these numbers, 5%, 12.5%, and 15%. And these are what we call relative frequency. So right back at the beginning of this video, I told you that we were going to be working on calculating relative frequency, which sounds like a fancy word, but it's really pretty simple. And it is. All we're doing is we are calculating relative frequency, or RF, by looking at the number of times an outcome occurs over or divided by the total number of trials that we've done. So relative frequency can be expressed as a fraction, 2 over 40, as a decimal, 0.05, or as a percent, 5%. Now it's your turn to find the relative frequency of each sum from your experiment. I want you to represent it as a fraction, a decimal, or a percent. You don't need to represent each one by all three, and you can change them up. So for example, if you want to represent the relative frequency of the 2 in a decimal form, great. Of your 3 in a fraction, as your 4 as a percent, whatever you like. But just remember that when we are finding the relative frequency, it's the number of times your specific outcome occurs, so either your sum of 2, your sum of 3, your sum of 4, your sum of 5, over your total number of trials. So when you're doing this, your total number of trials should always be 40, because that's how many times you rolled the 2 die. So go ahead, give it a shot, and when you've calculated all of your relative frequencies, come show them to me.